4.6 graphs of other trig functions. So what we're going to talk about sine and cosine real quick. Sine, where does it start? At 0. Then it goes up, right? How long does it take to complete its wave? 2 pi. Cosine, where does it start? 1. And then it goes which way? Down. And how long does it take for its period? 2 pi. Now let's talk about tangent. So I want you to get tangent in your unit circle in your head. You got it? Is it there? All right. So tangent's y over x, yeah? So what's tangent of 0? Tangent of 0. Tangent of 0. 0. Good. 0. All right. So that's why we have 0 right here. That's why it starts out at 0, 0. Now, what's tangent of pi over 4? 1. So that's why it goes up to 1. Now, what's tangent of pi over 2? It's undefined. It's 1 over 0, yeah? Well, when do you get a number over 0? At what? 0 over 0 is a whole. A number over 0 is a what? A vertical asymptote. That's why we have a vertical asymptote here at pi over 2. Okay? Now, let's do 3 pi over 4. So what's the tangent of 3 pi over 4? Negative 1. So that's why we got negative 1 here. And then, what about tangent at pi? 0. And then, what about tangent of 5 pi over 4? 1. How about tangent of 3 pi over 2? It's undefined, which means it's a number over 0. It's negative 1 over 0 in this case, which is still a number over 0, which means it's a what? A vertical asymptote. So that's how this is sketched out. It's really just knowing your unit circle. And hopefully some people have been writing this down, hopefully. Let's look at tangent again. Which way does tangent go? From left to right. In medical, we read left to right. Which way did it go? Up. It went up. True? How long did it take for it to complete its cycle of tangent? I go from negative pi over 2 to pi over 2, pi over 2 to 3 pi. How long did it take?
It takes pi.
It takes pi. So now the period of tangent is pi. Yes? And did tangent go through 0 unless acted upon? Yes. All right, so those are the things that I want you to think about. So your vertical tangents happen every what? Intervals of pi over 2's. All right? Negative pi over 2, pi over 2, 3 pi over 2. What will be the next one? 5 pi over 2. All right? And so vertical asymptotes happen on intervals of pi over 2. All right, let's look at this one. So now we have a period. So we have tangent of x over 3. Well, what's my normal period of tangent? Pi. Well, what did we do when we did the period of sines and cosines? We divided it by the what? The coefficient. So we're going to divide this by the coefficient. But now I have pi instead of 2 pi. So now I have pi divided by what? 1/3. What do we do with the dividing by a fraction? We do what? Multiply by its reciprocal. So this period is 3 pi. So now it's going to complete its cycle in 3 pi. Good? All right, let's look at this next one. So now we have tangent of 2x. All right, so I need to figure out its period. Well, what's its normal period of tangent? Pi. So I'm going to take pi and then do what? Divide it by its coefficient. So I'm going to divide by 2. So now it's going to complete its cycle in pi over 2. Make sense? All right, cool. We'll move. All right, so now, just like before, for sines and cosines on your shifts horizontally, you can kind of think of them as setting them equal to negative pi over 2 and pi over 2 because that's where your normal asymptotes happen. However, I think if you really understand your periods, it's a lot quicker. Okay? So let's do it. So this first one, we have tangent of x over 2. Let's figure out its period. So on its period, what's the normal period of tangent again? Pi. And then I'm going to divide it by its coefficient. What's its coefficient? 1/2. So what's its period now? 2 pi. All right. So what is my first vertical asymptote? This interval happens to be 2 pi. So I'd have to go out how much? Pi and negative pi. Instead of going from negative pi over 2 to pi over 2, now it goes from negative pi to pi. You basically half your period. All right? If you half your period, you get what? Pi. Okay, because now we have 2 pi, yeah? All right, and so I have pi and I have negative pi. Now, what does tangent normally do? Which way does it go? It goes up. And we're done. All right. Pretty good? All right. All right, this next one, we have y equals negative 3 tangent of 2x. All right. So if we can understand its period, we can do a lot with it. All right, so let's figure out its new period. What's my normal period of tangent? Pi. And then I'm going to divide it by the coefficient. So what's my new coefficient? 2. So now its period is pi over 2. Yeah? So where's my vertical asymptote? Pi over 4. Because it's half of it, and it's symmetric. All right? So now I have pi over 4, and we have negative pi over 4. Make sense? All right? Now, which way does tangent normally go? Up. Does this one go up? No. Why not? Because I got a negative out front. And what's the negative do? It flips it over the x-axis. So now we're going down like that. All right? Now, what does the 3 do? Let's see if anybody knows.
Stretch it?
It makes it go faster. Exactly. Remember talking about non-rigid transformations? This is a non-rigid. All right? It just makes it go fast. All right? Pretty good? But it basically looks like the same function. All right. Now we're dealing with cotangent. All right? So I want you to think of cotangent in your head. How do you think of cotangent on your unit circle? X over y. So what is cotangent of 0? It's undefined because you have what? The x is 1, the y is 0, right? So if it's a number over 0, it actually creates a what? A vertical asymptote. So now I have a vertical asymptote here at 0. Make sense? Now let's do cotangent of pi over 4. Think about your unit circle. What's the cotangent of pi over 4? 1. All right? It's the same thing over each other, right? And then what's the cotangent of pi over 2? It's x over y.
It's 1.
It's 0 because it's 0 over 1, right? The ordered pair is 0. 0, 1, yeah? So it's 0 over 1. All right, so that's why we crossed right there. And then what's the cotangent of 3 pi over 4? Negative 1. So that's why we're down here. Then what's the cotangent of pi? Undefined because it's a negative 1 over 0. If we have a number over 0, what does it create? A vertical asymptote. All right. Do you see how these all relate back to the unit circle? All right. If you understand your unit circle, I don't think that these are that hard. I really don't. All right. We can think through them if we truly know our unit circle. So which way does this cotangent go? It goes down. Do you see why it goes down? With our unit circle, it goes down. All right. Now, where do we have vertical asymptotes? A number of 0, true that. At 0 and intervals of what? Pi. All right, so all my pi's, I have a vertical asymptote because that's where I get a number over 0. Does that make sense? What's my period of cotangent? Just like tangent, what's my period? Pi. All right, pretty cool. So now my vertical asymptotes are 0 and pi. However, I don't usually go that method. I just kind of think about its periods. All right, if you understand its period, you can do a lot with it. All right, you ready to play? Let's do another one. Here we go. So now I have 2 cotangent of x over 3. 2 cotangent of x over 3. Let's figure out its period. What's my normal period of cotangent? Pi. So now I'm going to take pi and divide it by what? 1/3. So now what's my new period? 3 pi. So where are my vertical asymptotes? At 0 and at 3 pi. All right, so I'm going to make that 3 pi. Which way does cotangent normally go? It goes down. Is this one going to go down? Yeah. Yes. All right. Where's it going to cross? It's in the middle. Where is the middle? 3 pi over 2. All right. And so it's going to cross in the middle like so. All right. Pretty easy. All right. Fantastic.
It goes down.
Talk about secant and cosecant. All right, or cosecant and secant. But before I talk about secant and cosecant, or cosecant and secant, I want to talk about their reciprocal functions. All right. So cosecant is buddies with who? Sine. Don't try to graph cosecant without graphing sine. Okay, does everybody hear me? And don't try to graph secant without graphing cosine. All right? They're reciprocals of one another. This is what we want to do here. All right? So I want to actually think of sine before I try to do cosecant. Okay, so we're going to talk about sine first. What's the sine of 0? Where does sine start? At 0. And then, where does it end? At 2 pi, but it's at 0, right? And then it crosses in the middle, and then it goes up at our quarters. Remember? Right? So if that's what we have, if the sine is 0, the cosecant, if you flip it, what happens? It's undefined. If you flip 0, it's undefined. Remember? Remember, if you like it, you put 1 under it. Remember that? All right, Ormy does. Ormy loves songs. All right, so if you flip 0, you get undefined, right? And what is undefined graphically? It's a vertical asymptote. So my cosecant has a vertical asymptote at 0, as well as it has a vertical asymptote where? At pi and at 2 pi. And then it's the reciprocal of it. So if we have our maximum going at like pi over 2 for sine, guess what it kind of is for our cosecant? It's a min. All right? It kind of works like a relative minimum. All right? And the same thing, the minimum for sine is actually going to be the relative maximum for cosecant. All right? See how that worked? All right, let's do it again for secant now. I don't want you to think of secant right away. What do I actually want you to think of? I want you to think of cosine. All right? So let's think of cosine now. Where does cosine normally start? At 1. And then which way does it go? It goes down. So it's going to cross at pi over 2. And then it's going to have a minimum at pi. Then it's going to cross at 3 pi over 2. And then it's going to cross or go to its maximum at 2 pi. All right? So we should know that about cosine. Yeah? And wherever it crosses at 0, what do we know is happening at secant or secant? Yeah. It's our vertical asymptote, because if you flip 0, you got a undefined, which means it's a vertical asymptote. And where you have a maximum is where you have a relative minimum. And where you have a relative minimum is where you have a maximum. Okay? All right. There's a couple things I want you to notice. All right? This is the kind of giveaway stuff that I want you to think about. Cosecant goes with who? Sine. Sine starts where? Sine starts where? At 0. Sine starts at 0. So, does cosecant get to cross the y-axis? No. Unless shifted, it doesn't cross. Does everybody see that? All right. Where does cosine start? 1. So, does secant get to cross the y-axis? Yes. That's the way I'd think about it. All right? Pretty nifty? All right. All right. Let's graph one. All right. Let's make one up. All right. So let's make one up. So we got y equals, pick a number.
17.
Ooh, it's huge. Let's pick like less than, let's like 3 or, 3 sounds great. Positive or negative?
Negative.
Which one?
Positive.
Positive 3. Cosecant or secant? I don't care. Secant. Love it. You want a variable? Yeah. Let's pick it. Let's pick a coefficient with a variable. What do we want? 2x. All right. I like it. All right. Cool. So we're going to graph 3 secant of 2x. That's what we're going to graph. All right. But I would not start at 3 secant of 2x. I want to start with the cosine. All right. I want to start graphing its buddy. All right. It's the reciprocal function. All right. So now let's graph this guy. So where does cosine normally, first of all, what do we need to check? We need to check its period. What's the normal period of cosine? 2 pi. And I'm going to take that and divide it by what? 2. All right? So now it's going to complete its cycle in how fast? Pi. Okay? So we're going to complete its cycle in pi. Sound good? All right. Now, we got pi over 2 in the middle, and then we got pi over 4. Remember how we kind of break them up into quarters? All right. So where does cosine normally start? Normally starts where?
1.
At 1. Well, now it's not going to start at 1. It's actually going to start at what? 3, because my amplitude is 3 there. Yeah? And then what does cosine normally start doing? It starts going which way? Down. And then it's going to cross at what? The quarter mark. And then it goes down to pi over 2. And that's where its minimum is. Yeah? And then what? It goes back up to 3 pi over 4. And then it goes back up to at pi, it reaches 3. So does everybody remember how to graph cosine? All right. So now that we have cosine, now it's really simple to build secant. All right. So what happens when it crosses the x-axis? That happens to be what? Our vertical asymptotes. And so we have vertical asymptotes going on right there. And then where we have a maximum at, guess what happens? We have a min. And then where we have a minimum at, we have a max. And so I would start looking like a graph like that. All right. So if we were to graph cosecant, what would I ask you to graph first?
Secant. Or not secant, sine.
I'd ask you to graph sine. Okay. All right. Let's graph one. Here we go. Let's review all 6 trig functions now. Are we ready? Let's do it. All right. Sine. What's its period?
2 pi.
2 pi. Where's it start?
0.
0. And it starts going which way? Up. What's the range of sine? What's the lowest y value we get for sine?
-1.
-1. What's the highest value?
+1.
+1. So it's in between -1 and 1. Good? All right. Cosine. What's its period?
2 pi.
2 pi. All right. Where's it start?
1.
1. And which way does it start going?
Down.
Down. We got that? All right. What's the range of cosine?
-1 to 1.
Awesome. All right. Tangent. What's its period?
Pi.
Pi. Which way does it go?
Up.
Up. Does it get to cross the y-axis?
Yes.
Yes. So where are the vertical asymptotes normally?
Intervals of
Pi over 2 and
-5.
negative pi over 2. All right. So there's our normal ones, unless having a new period. Does that make sense? Or shifted, I guess. All right. Cotangent. What's its period? Pi. Which way does it go? Down. Does it get to cross the y-axis normally?
No.
No. All right. Where are the normal vertical asymptotes?
Pi.
At intervals of
Pi.
pi's. All right. Cosecant. Before you graph cosecant, who would I think about?
Sine.
Sine. I would graph sine. Where does sine start?
0.
0. So does cosecant get to cross the y-axis?
No.
No. What's the period of cosecant? 2 pi. Secant. Who's his buddy? Cosine. That's where I would think first. Where does cosine get to start? At 1. So does secant get to cross the y-axis? Yes. What's the period of secant?
2 pi.
2 pi. All right. Pretty good? All right. Here we go. And there's your homework. There you go.